Okay, year 12. So with question 4 then, blah, 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 blah. So I'm just talking about a tree and planting. And then it says using a linear model. So a linear model is something like y equals mx plus c. That's a straight line, linear. But in this case, we're not dealing with it in terms of x and y. We're dealing with it in terms of h and t. So I'm going to write out that h equals a t plus b, and a and b I can find their values. So exactly 3 years after planting, the height was 2.35. So I can get 2.35 equals, and then t is 3, so 3a plus b. And then what else? Exactly 6 years after planting, the height was 3.28. So 3.28 equals 6a plus b, if I just call these 1 and 2 for now. If I do equation 2, subtract equation 1, we can solve this like a pair of simultaneous, this is a pair of simultaneous equations that can be solved. So 3.28 minus 2.35 is 0.93 equals 3a. So therefore a equals 0.31. After that, to find b, I would just substitute. I'm going to sub into 1. So equation 1 says 2.35 equals 3 lots of 0.31 plus b. So then 2.35 equals 0.93 plus b. And then to find b, we subtract 0.93. So b equals 1.42. Okay, so then finally, just writing our equation now that links h and t. H equals 0.31 t, or t plus 1.42. And that's my final answer for part A. Now for part B, the height of the tree was approximately 140 centimetres when it was planted. So when it was planted, the t would be 0, okay? Because t is the number of years after planting, so t would be 0. So what I'm going to do is I'm going to substitute in t equals 0 into my equation. So when I substitute in t equals 0, I would get h equals 1.42, which is 1.42 metres, which is 142 centimetres. Now 142 centimetres is really quite close to 140 centimetres. So yes, the model suggests the initial height is 142 centimetres, which is close to 140. And that's it for question 4.